while loops are the new control structure that we're going to be talking about today. And a loop allows us to repeat a section of code or a code block to run it repeatedly while a condition is true. Okay, so we're always looking for a while this condition is true, we do this thing. You'll notice there's some structural elements to this that are similar to an if statement, right? We've got while, the keyword, an expression that evaluates to true or false, a colon, a code block that's indented. The difference is this code block will be executed over and over and over and over, forever and ever, or until the computer dies, as long as this is true. When it becomes false, then it is no longer executed. Let's take a look at how that works in practice. So if I have x equals 1, and I say while x is equal to 1, print x equals 1. Okay? I can do that, and it's going to print x equals 1 until my computer can no longer function, until it runs out of batteries, until somebody hits it with a hammer, until it falls off the desk, until it gets so old that it burns out, which will be a very long time. By the way, this is running, you can't really tell by looking at the screen right now, but this is running so fast that we've probably printed 10,000 lines by now. Just as a quick example, here's something I can do. Instead of x equals 1, I'm going to say if x is greater than 1, greater than or equal to 1, I'm going to print the value of x inside an f string. And now I can see exactly how many times this thing is printed by just, remember this increment operator? What does this say? This says x is equal to x plus 1. So take whatever's in x, add 1 to it, put it back. That's a shorthand. I could also write it like this, x equals x plus 1. Okay, but plus equals is actually significantly faster if you're doing it quite a bit. So now, what's going to happen here is we start the program, x equals 1, and then we encounter this while statement. It says while x is greater than or equal to 1, it is, that's true, do this. Print x equals, and then the value of x, and then add 1 to the value of x, and then repeat it, because we're in a loop. So now it says, now x is equal to 2. It says while x is greater than or equal to 1, x is greater than or equal to 1 because it's 2. When will this stop? Again, never. But you can see how many lines we're printing here. We're already at almost 500,000. Now, when Python was created, I told you this before, computers were a lot slower. So, you know, this running on this modern day operating system with these chips, it's really going quick. So if I wanted to, I could slow this down. Okay, I could say import the time library or the time module, and this allows me to pause time dot sleep for 1 second. Now, in my loop, after it increments x by 1, it's going to pause for 1 second. So now it's basically counting off the seconds. Okay, so now I can keep track of how many times it's been through the loop without getting into the millions before I can even blink. So, how would I break this loop? Because right now, what I have here is basically the same thing as if I just wrote this, because it's always going to be true forever and ever. And in fact, this does work. If I want to create an infinite loop, that's how I do it. Yes. Because it's an increment operator. Plus equals stands for x equals x plus 1. That's a shorthand. It's called an increment operator. Yeah. So if I want to stop this loop, I should create a condition here that will eventually no longer be true. What's something I could put in here that after a little bit would break out of that loop? What do you think? Any ideas of what I could put in there? While x is less than or equal to 50, x is less than or equal to 50. You know what? I'm going to reduce my time factor by 10 because nobody has time to wait until we're all the way to 50. But let's see what happens. Okay, there we go. Count to 50, and then we stop. Well, actually, technically, we count to 50, and then we go to the next line, which doesn't exist, so the program stops. So that is how you do a loop. And of course, if I say while false, it's just going to yell at me. It doesn't like this. That's why it's highlighting it. It's not technically an error, but it's like, hey, stupid, that's never going to execute. Okay? So that is the most basic form of a loop. And so when we're talking about loops in our code, that's how we do them. That's the easiest way to do a while loop, is to set up a condition where eventually it won't be true anymore. So while x is less than 10, where will this stop? What's the last number that this will print? 9. So you got to think, if you want something to count to 10, you don't want to do that. You probably want to do less than or equal to 10. You could do less than 11, but for the sake of making your programs more usable, you've got to think about what's a more understandable value. For example, if you asked the user, what number should I count to? If you do less than or equal, you could take that number and plug it right into the loop. Otherwise, you'd have to add 1 to it, and you're starting to do all of these sort of gymnastics with your numbers that make things more confusing. So you want to think about that sort of thing. So ending a while loop, we want to use this sort of syntax where we know that something is not going to be true at some point. And you really want to think about, unless you want your program to just run forever and ever until you stop it, you want to think about what am I doing that's going to make that not true? How am I going to get out of this loop? Because a lot of times, people will write this part of the program and leave off this, in which case x stays 1 forever, always stays true, and we don't stop at 4. And they're like, why didn't it stop at 4? Or why didn't it stop at 3? Because you didn't create a condition where it would. So you got to think about that.